Now we're going to look at spanning trees. So a tree is a network that has no cycles, multiple edges, or loops. So we can see here from vertex D, we have all of these edges coming off, but none of them then connect. So same here, I have no edges that join together to make a cycle. They're all just ending at their own points here. And whereas these ones below, these are not trees because it all joins up. Okay, I can get around to each one following a path. Okay. So a spanning tree is a tree that connects every vertex of a network, but there's many different trees for that network. So you might draw one that's different to the way I draw one, and that's fine, so long as none of them join together to make a cycle. So what we need to do is construct a spanning tree for this network. So the best thing to do is draw on each of the nodes or the vertices, roughly, doesn't have to be perfect, where they would go. Oops. Yeah. Just so you can get a rough idea of where those vertices are. Now, what I'm aiming to do here is, it doesn't matter where you start either, you can choose anywhere to start, but you are not wanting to make a cycle. So I wouldn't want to go from B to F, F to B, B to A to F, because that would make a cycle. All of them then join together. So instead I might just go F to B, B to A. I'm not then joining A to F because that would make a cycle. I could go B to C. I'm not going to join these two because that would again make a cycle. I can go F to E. Now you've got two options here. You can go C to D. You could go E to D. You could go F to D. Doesn't matter which one you choose. Same as before, I might have chosen to go from A to E instead of F to E. Okay, we could go like that. Usually what we do is we choose one vertex and we go from that vertex to get to all of the points if we can. But again, it doesn't matter. So there's multiple different ways to do this, and it's not incorrect if you have a slightly different one to the one that I have here. So it says down here, which is really important, the number of edges in a spanning tree is one less than the number of vertices in the original network. So if we count how many vertices there are, 1, 2, 3, 4, 5, 6. Okay, so the number of edges is one less than the number of vertices. So 1, 2, 3, 4, 5. So we can see I had 6 vertices. I have 5 edges here. The number of edges in a spanning tree is the number of vertices in the original network minus 1. And that's proved that there.